Ladies and gentlemen, please welcome our next speaker, Hans Preishuber, presenting the topic, Step into MachineLearning.net.
Do you hear me? Now you hear me. So it's pronounced Hannes. Yes? Please repeat. Hannes. Thank you very much. It's not Hannes. Okay. So you can ask me questions about Austria. I'm from Austria. You can ask me questions about old Vespas, how to fix it. I have 4 pieces of them, down from 7. You can ask me things about PPDV, the company. I founded 30 years ago, and we do training in the German-speaking market, also Germany, Switzerland. You can ask me about ML.NET, machine learning.net for Microsoft Framework. This is the topic of this session. So my goal is, 40 minutes is very short, my goal is to give you an idea of what you can do in your existing .NET code to use AI capabilities. So we have to do some basics. What you're talking about, stolen slide, so it's not from me, and take care. First thing, if you're thinking about machine learning, you have to think about data science, to prepare data, to get data, to transform data. This is really a science. That's the reason there's science inside. And if you have shit data, you get shit out in any case, what you do, which framework you use, and so on. About machine learning is artificial intelligence. This is, for my guess, what OpenAI is doing at the moment. And within machine learning is deep learning, which is something you can read books about. That's like that. Where you build your models. So the ugly side of machine learning is what you're thinking about, or what is our future, and I have really bad examples here on the slides. What you can do, perhaps somebody know the PIC video, the movie where it is from? What? Minority Report. Who have not seen Minority Report? This is a question of age. So in Minority Report, they needed mankind to predict crime. We can predict crime, and that is not a joke, indeed, with data from computers. We can divide in good and bad citizens. We can track people moving around in systems and fake people moving around in systems. This is really reality now. So if you go to China, they have this technology working for you. The most modern thing is large language models, here, the OpenAI story. And there are several issues which you have seen or go through the press, which such that. And the last point is that's our future. Skynet will take over. And I will show you how you can do that and participate in Skynet and be the slave of Skynet and survive in this system. My part is, I'm not a big fan of cloud. I think, this is my personal believing, I think the real excitement with AI is to have it on small devices, and these small devices are able to do things without any user interaction. So this is a Raspberry. So my talk is about how you can use AI, machine learning.net, without targeting any API from Asia or Open API, and don't get the bill at the end of the month from them. And if you have watched what the market is doing at the moment, you see that NVIDIA stock goes up and up and up because they sell graphic cards with CUDA command set, because the market seems to have a need for that kind of solutions. The question is, can I do such things? Can I do things like OpenAI is doing? And the answer is, yes, you can. Somebody knows these guys? This is from a French company. They developed Mistral. This is the whole team. 2 years. Within 2 years, they developed Mistral, and this have the feature set of OpenAI 3.5 roundabout. You can download it and use it. So we are in a field of technology which we can participate, use, or create. I have the same for Microsoft, because this talk is about Microsoft, MLNet. This is the team from MLNet a few years ago, working hard on things we learn in a few minutes. Large language model, the topic which is in every media and so on. This is my last slide, and this will be my last demo to show, can I use a large language model within my existing .NET application? The answer is yes. And Microsoft have done Pi3, which the funny name, tiny large language model. That's the reason for the picture beside. And I will show you how, it's not my last slide, how you implement that. So, before, a little bit how to do it in detail. So I have a picture here on the side and some notes here on the slide. Okay, ML.NET is a library from Microsoft. They say it's open source, it's vendor driven, and it targets all relevant operating systems. The usual story which Microsoft is telling today. What you're doing with machine learning, you solve problems you cannot code. And ML.NET is a little bit complicated to describe. So the easiest way is, if you know entity framework, think about the entity framework for AI. Entity framework is targeting different kind of databases with different kind of schemas. So you need context, you need model classes, and so on. And this is nearly the same in ML.NET. It's called ML context, not DB context. And you create the context, you create a pipeline. The pipeline is the most complicated thing in this game, because you have to ensure that every data that you put in your pipe or in your code is fitting in your model. Size of data, labeling of data, and so on. This is not so easy. This is a data science job. And you configure the pipeline to transform your data in the format you need or your model needs. And then you train your pipeline. So you take your data, make a training, and create a model. And after the training, you evaluate with usually a smaller data set and say, okay, let's try it. Is the expectation of the output of a model that what my evaluation data set says? And if this is okay, go back to the graphic, then you have the opportunity to save your model. And if it's not okay, you have to redesign your data, retrain your model, and save a new model. And with a saved model, you can go and predict anything you want to predict, good or bad citizenship. I have one slide, this is indeed the last slide, where there is code in it, so you can get a feeling about how it is built. So we see a model context, we see that we have to load some data, we see the pipeline in step 3, where transformation is done from features. Features is a typical description of the data, and labels, which is the expected output of the data. And then I can say, okay, train your model in step 4, and then you can, in step 5, predict with some thing you want to predict. Okay. That's the point. So hopefully everybody of you have seen Visual Studio. I'm not sure. I have not seen any Visual Studio in any session. So I create a new project and this command line. And the goal of this demo is, here is this right, to show what Microsoft is, oh my god, what path I have. And I call it delete me one. So, yeah, funny part, I forgot to switch the language of Visual Studio. Is somebody here who can speak German? Oh, thank you. For you two guys, I make this demo. So, Windows. So, what I have to do? Microsoft have a new model builder, and I find this here. So you have to install this part without you have not this part. And with this model builder, I can do several things. So, German, sorry about that. We have tabular data. Tabular data is normally some Excel sheet or something like that in different formats. And then you have 4 different scenarios which you can use. For instance, classification. Yeah, we have this. It's the first one, classification. And you can say with this sentence, we can believe that this guy is angry. That's a classification task. We will do some machine. I'm missing English word. Maschinelles Sehen. Good question. And the last one is, you see the UI is looking a little bit fancy, is also text classification based on context text, not on tabular text in the first case. So we are going to doing some image classification, and I do the smallest and fastest thing I can do. So this takes time. That's a problem. And I have a data set. I choose this folder, and you see here triangles, circles, and so on. And I have labeled this data in folder. So the idea comes from what? The idea comes from whiteboard. Looks fancy. So if you go into whiteboard and draw a triangle, so looks really ugly. Okay, doesn't work. That's always the best demo case ever. Why it doesn't work? Because I have no internet connection. I didn't check the internet. So my expectation is that this triangle would be a nice triangle. It is not. Next try. So this is a feature of whiteboard. I hate whiteboard because it needs a internet connection, so it's not suitable for airline plane flight or so. So and my idea was, okay, let's try to rebuild that offline with ml.net. And for that, I have to create data. I have done that. You see the data here, and I have written a Blaze application for creating the data to draw with my pen on my Windows machine. And I have put it in 3 directories, and now I can start the training. Where is the button here? Now, what I'm doing now, this is called AutoML, and the tool you see at the moment is the model builder. These are the Microsoft names for that. And you can do that with tabular data or whatever data. You have to figure out what kind of machine learning task do you have, what math algorithm fits best in this thing. This is your part. Then you go here to this tool and say, okay, this is the best one. Put the data in, train it, and at the end you get a ml.net model. Takes not so long, 1 minute. So, and I have talked about the quality of the model, and one is unbelievable but true, not a good quality. One is the best, but if you have one, then you have a problem in your data. So I have a problem. I don't know which problem. It's not time to fix that. And now I can do following thing. I can take a circle, this wonderful circle, and predict if this is a circle. So 99% looks quite good. I take a different image which is not from my training data, because this is not fair. So we have that. That awful triangle. Takes a while. And you see Dreieck is triangle, so it works quite well. And if you want to use that model, which exists here, ml.net, you have just do the following thing. Nutzen. That's Microsoft. Use the first code snippet, paste it to your project, or click the second option. So, and now I have really, so it takes 2 seconds. I have 2 projects in my solution, my Visual Studio solution, and the second one is able to use this. I can run it. Also, I have to set the start project. So I start project, and so this is the picture. It's a PNG, and now I have a command line tool where I use this model, and you can use it in your code. So you see, same. It's the expectation is it's a triangle. Okay, so we have seen it's not so complicated to do that special task, but if I take a look at this, you have a different task. You must figure out how big is your triangle and where it is placed. Not so good. And this is a little bit more work. For that, you can do the training in Visual Studio. You can do that, but I have not reached the results that it works. It takes long time, and at the end I get the mess model. And there are always 1000 possibility to do something in the AI field. There are so much tools there, and this is from Microsoft. This is Custom Vision AI. It's wonderful. It's wonderful, cheap, and fast. It works excellent. Okay, so I uploaded my images here to this tool. I do a training, this green button, and all done. We can see here, and Microsoft say this is a quite good model, evaluation of the model, and I can do a prediction. And I've also loaded an image here, this one. So you see I have 3 figures in this image, and this model have the ability to figure out where are the figures and make the dimensions or detect the dimensions where it is. And you see also there is here a Viereck with 27% more than figures here on mine. This is typical for models. Models are never perfect, so they are always have some side results, and it's on you to say what is your number where you say, okay, this is for me okay. So Viereck So you say 30% is at least the number you need, and everything under 30%. But this is, you have to figure out that in your dataset environment and code. So now that's a, where it is, here it is. That's the point I want to show. You can export this model. And you see different kind of models. This is the model ecosystem. I will show you in a minute the hosting platform for models. And Microsoft have created Onyx and say it's an open source format, so you can exchange models. And we have also TensorFlow, which is from Google, which is quite famous, and others. So I can download the Onyx model and use it in my project. I have done that with a UWP application with Windows ML, which is not ML.NET, and this works. It works really good within minutes. Okay, what I want to do, I want to download it as a TensorFlow model. I have that somewhere. Ta-da-da-da. TensorFlow model, here it is. So I downloaded this model, I'm sure it's this model or another, as type TensorFlow, and this is a model. Round about 60 megs. And if I double click this model, I can take a look at the error message, click OK, and look in this model. This is a tool which is developed from a Microsoft guy in free time, Neutron, and you can take a look. How is this model built? Yeah, you say there's a placeholder, and this has the type of placeholder. And if I go down, somewhere is the model ready, or the output is ready, and this is called model outputs. This is important if you want to code this model and have no idea how the model is built. And this is the point I do here. So I show you a little bit the code. So first step, model context. Second step, load the data. Yeah, some images. Here, load the data. Next step, create the pipeline. This is an important part. Resize the images, extract the pixels. And if you remember, 20 seconds ago, placeholder was the input of the model. That is the reason why it's called placeholder. Placeholder is a silly name for that. And then it's load TensorFlow model, because I have a TensorFlow model and no Onyx model. I will show you Onyx model a little bit later. And here I have an input-output column, model outputs. You have seen that in the model. And then I can train the model, create prediction engine, predict, blah, blah, blah. The labels are separated in a text file. I can show the labels. So this depends on the model if the labels are in the model or not. The reason is AI always uses numbers internal, never strings, so it have to transform it internal, also language models, to tokens. And this is the reason I have this label table. And here I have a object detection, blah, 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 and can run this code. This is also command line code, and say, and check, hello world, load the model, hit the breakpoint, click and say Kreis. Okay, circle. It's called here Kreis. You see, it's a Kreis. And it's not from my training data, it's a different Kreis. Okay, we want use cases you can use in your daily business. Next one. Oh, I should not close Visual Studio. Next one. In Germany and Austria, people like to have bathrooms without toilets. Is it here also the same? No? Yes? So a flat costs more money if it have a separate toilet. So, and the point is, if you're selling 50 minutes, if you're selling flats and say, okay, toilet or no toilet, this can be wrong. So somebody must look at the picture and must say, do I have a toilet or no toilet? And this can AI do. And this is a Kloschüssel demo. Kloschüssel is toilet in Austria. And what I have done, and this is really the case, oh, where are the pictures? Where are the pictures? Where are the pictures? I've forgotten all the pictures. I've downloaded pictures or images from the internet from bathrooms with or without toilets. I have here somewhere the I've forgotten where the path is. Next. Usually I open all this stuff, but I closed something. State of Kloschüssel. Kloschüssel. Images. Mit? Ohne. Okay. So, looks like that. So, that are my training data. They are not normalized. Different size, different format. 50 pictures mit and 50 without. This is the extra große. So you can see, you can see my bathrooms. So that's a training data. I have really done that. So I trained this. I show you before how I trained that. And now I have a bathroom without. I can also take a house or a car or whatever. It works. And what I've done, same thing with AutoML model builder, created the second project. And when I run this, it says, as we have seen before, bathroom or no bathroom. Ohne. Ohne means no toilet. So, use case. Can you really use that within minutes? Next use case, handwriting, and there is a large or huge data set, quite old in the field of AI. It's called MNIST, and it's the target is, or the goal is, to detect handwriting. And you see here zeros in different kind of matter, and they're all the same size and all the same look alike. This is done by some data scientists. And for this MNIST, there are also existing models. So you're not going to build your own model. So you can say, okay, take a model. And there are different platforms for that. And you can use this MNIST model within your Visual Studio. I drop this demo because of time and go to the next existing model. One of the famous existing model is YOLO. So let's go the break there. So YOLO, here here I have tiny YOLO version 2 in Onyx format. So I go to somewhere and grab this model, download it, and put it in my project. On YOLO is have a target to detect different kinds of objects. I think 7 or 8 cars, peoples, chairs, not sure. Dogs, cats, and something like that. And I have this downloaded, and I have here code. And if you have or you remember my previous demos, you see that looks like a little bit I have done before. Yeah, something is doing a model ML context and then loading data, create a pipeline, transfer the things, because there is called image input and output, and so on and so on. And now I have also a use case, for a practical use case, and the question is, I have two AI. You cannot see that. Is this a car? Who believes that this is a car? We will take a look at the opinion of AI. Okay, so I have this picture with a car here, and I have different pictures here. For instance, okay, for instance, oh, that or that. So this is a demo application from Microsoft, so it's not from me. And the pictures from her. You have seen pipeline, model, studied. And now we predict what is on this picture. You load the model, you get the scores, it gets quite fast, and you see different things. You remember the last picture, dog, score, person, dog, person, person. So on this picture are 2 dogs and 3 persons. We take a look at and prove that in a few seconds. The interesting question is that the car? And AI is not sure. 51%. A person is on the picture. And the bonus track of this demo is, where is the pass? I have opened it. I've closed it. Okay, I have to take a look in the code course. The pass is quite complicated. Where is the pass? Pass. Model Scorer. Da bin ich doch. Programm. Oh. Ja, hier ist der Pass. So this is the pass of the pictures, and this code produces output pictures and creating the bounding box. So this is produced from my code here, which is stolen from Microsoft because this is a demo project. So you see the car is marked and the person is marked, and you see also the percentage where this model believes that pictures and people on this. So, and what is the use case in the reality? So you can grab a picture of a webcam, because this is really fast. Grab a picture of a webcam and checking what person or dogs are passing by your whatever system, China. Okay, so you have seen YOLO model using. And now we are going to the last interesting thing, large language models. Yeah, So, and I say there is a platform for distributing models and tools and whatever. And this is called Hugging Face. So you go to Hugging Face, searching for a case and a model, and download the model. It's free, it's open source. And Microsoft released a few weeks ago Pi 3, and from Pi 3 there are different variants, which the difference is from the training data and the size of that. So this is the smallest one, Pi 3 mini 4K instruct, whatever that means. So this is the small OpenAI, and I can ask this different things as you please. Add 1 + 1. It's quite easy. 2, yeah, or solve 6. So it's a little bit chattier. Okay, so it can code, it can answer different questions. The dataset is 2 gigs. So it cannot everything, so it knows not everything. The training data which Microsoft uses is quite small, but contains a lot of. And the goal is, okay, can I use that in my Visual Studio, my .NET project? And yes, you can. You can. 6. Okay, here it is. It's not much. This code is not stolen, but there is a project for Pi 2 on Microsoft side, and I used this code and adapted it for Pi 3. It doesn't works if you use it one-to-one, and I have to guess some parameters, which you will see it's quite funny at the end of the day. So here is my model, and this is 2 gigs of data. And back to MLNet, I create the model. Here the steps are a little bit different because you have no images, so you have text, and text needs to be tokenized. That's very important to create numbers from tokens, or from text numbers, which are called tokens. And then I encode the input to tokens. And how LLMs works, it's a little bit complicated, I pass it. And then I say, tokenizer create stream, it's not so important. And then I have a loop, because you have to create tokens and tokens and tokens and tokens. This is how OpenAI also works. So every new word is created from the past. And yeah, that's the part. And you will see that the results are different to the web chat, because I do not know how the parameters work. There's no documentation at the moment. Solve 3x plus 6. So I have no idea why here is 5x, but it do something. And you can yes. I have limited the result sets to, I'm not sure, 400 or 300 characters, so you do not see the result at the moment. No, it's here, 0.5. Okay, it's wrong. No, it's minus, or -6. It's wrong. Okay, I have no idea. It's quite funny, but it's not a thing of ML.NET. It's a thing of the parameters I do not know. I have guessed the parameters how to use it. So what is the use case of that? So I don't want to chat with my .NET code or with my .NET application. The use case is, for instance, back to my single chip solution, to run such a thing on a single chip and to switch on or off the lights. You can communicate with your machine. You need a function call, something, an API call, and can switch on or off your lights. This is the future, I think. And this is the end, I think. Okay. Yes. Questions?
Thank you, Hannes. So we are opening Q&A session, and there's the first question you can see in the screen from Slido.
You see the question? No, you see not the question. I have to repeat it. Here's the question. Yeah, thank you. So first time I hear, sorry about that. Yes, you have seen that. I was very, very fast on the training step. I have still the project open. Delete me. models. That one. Training. No training. Here it is. So here's the setting. So you have 3 choices at the moment. For GPU support, there's something changing from Microsoft side, and at this point, there's no longer CUDA needed, and you can do it in Asia. So Microsoft want to sell you Asia. Please buy Asia. Now, next question. So advice for training data. Yeah, hire a data engineer. It's the truth. It's not my experience. It's so hard for me to understand how must the data look like, and I have invested so much time into understand how the algorithm is working. And for instance, image detection. It's so complicated, or large language models with the vector sinus similarity. You have to understand that to make data which the systems can use for good models. And if you have not time for that, hire a data engineer.
Thank you. Now we are out of questions, but maybe someone wants to use this opportunity and ask just straight away. If no, then we'll have Hannes in Ask Me Anything corner. So thank you very much.
Thank you.